This tutorial describes the operation of the device HM132, which serves as a tool for visualization and study of fluid flow phenomena and patterns. The primary purpose is to visualize and analyze the behavior of water as it flows over or through solid models. The water flow is seeded with bubbles that are created by electrolysis. The bubbles follow the fluid direction, allowing to visualize phenomena such as boundary layer development, vortices, separation points, and turbulence. The objective of this laboratory is to study two-dimensional flow fields around bodies of different shapes, visualize and describe streamlines, flow separation, vortex formation, and flow conditions. Different solid models can be affixed to the panel, and photos and video can be recorded at various testing conditions. The models include cylinders, airfoils, and prisms. Remember, the TA or instructor is the only person authorized to change the models. Ask the TA to change the model when needed. The models can be analyzed under various flow velocities and data recording as photos or videos can be obtained at different exposure conditions and frame rates. The use of the high-speed camera will be described later. Refer to the specific lab guide for detailed information. The HM132 flow visualization instrument consists of several key components designed to facilitate fluid dynamic testing. These components include the storage tank and a pump. The pump makes the water circulate through the system at variable velocities. The system uses distilled water. Sodium sulfate decahydrate salt is added and dissolved in water to increase its conductivity. A honeycomb structure that helps the flow to become uniform, stable, and fully developed. The bubble generator consists of a DC electrical system that passes a current through a platinum wire. The wire extends across the test region and seeds the flow with hydrogen bubbles created by electrolysis. The bubbles flow the fluid path, displaying the fluid flow field. The test region is where models are affixed and the flow fields are visualized. The dimensions of the test region are 860 millimeters in height, 300 millimeters wide, and 49 millimeters depth. The degassing tank helps remove the bubbles pumped by the system. We are now ready to begin the experiment. Before operating the machine, make sure to wear safety goggles and adhere to laboratory safety rules. Note that this device can be operated with or without its software. The operation of both cases will be described in this video. For direct or manual operation, that is, without the use of its software, use the control switches on the front panel. If software is required, log into the computer and open software HM132. Turn valve V1 to filling. Always turn the valve clockwise. Turn the main switch on. Turn valve V2 to max V. For direct or manual operation, turn the illumination switch to internal. The light on the vertical chamber must turn on. For operation through the software, turn the illumination switch to external. In the software HM132, click on the steady light icon. The light on the vertical chamber must be on. Press the pump switch once to turn it on. Water will start flowing into and filling the degassing tank. The following step must be done before the water reaches the overflow sensor. Rotate valve V1 clockwise to operation when the water level is between the water top outlet and the overflow sensor. Wait 1 minute for the water flow to stabilize and bubbles to disappear. For direct or manual operation, turn the pulse generation switch to internal. For operation through the software, turn the pulse generation switch to external. At this point, a current is ready to pass along the wire to generate the bubbles. When using the software, look for the Operation Mode section and click on the icon Continuous. For both methods of operation, the current must be adjusted using the current knob. Set the value to 100 milliamps or the value indicated by the laboratory guide. Remember that the current magnitude must always be less than 150 milliamps. Bubbles must be flowing along the chamber. If not, ask the instructor for help. If needed, the flow velocity can be adjusted by adjusting valve V2. You may start taking pictures or video of the flow field. Open the software CameraWare. The software should recognize the camera immediately. If not, notify the TA or instructor. The current camera view should be displayed. Click on Preview to initiate the video. Adjust the black and white or BW setting if necessary. Press right on the current view and select either Auto Range Peak or Auto Range Crop until a clear image is obtained. This step must be repeated every time the exposure time is changed. If video is not displayed, close all windows labeled as Camera 1 Pico.Pixelfly USB, click on View first, then click on Preview. You may need to turn the lab light off to avoid reflections. The camera should already be focused. If not, ask the TA or instructor for help. Do not focus the camera by yourself. Modify the exposure time by entering the desired value. Remember to adjust the black and white or BW setting every time the exposure time is changed. Set the number of pictures by selecting Acquisition in Rec Memory Settings. Insert the required number of pictures. Do not change any camera parameter unless required by the laboratory guide. At this point, you are ready to start taking pictures. Click on Record. This will stop the current video view. To take pictures and save the sequence automatically, click on File and Direct Record to File. This creates a file extension .picora, that can only be opened within the CameraWare software and contains the entire sequence of pictures. A window will appear for you to select the destination folder. Insert an appropriate file name. Make sure to change the extension file to .picora and insert the number of images when saving the file. Press OK. Insert notes if necessary and click OK. After pressing OK, the camera starts taking pictures and saves the file in the selected destination. To convert or export your pictures to a JPG extension, go to File and select Export Recorder Sequence, Not Reloadable. A window will appear for you to select the destination folder and insert an appropriate file name. Press OK. Accept the adaptation of the file name by clicking on Yes. All the images will be saved as JPG format in the selected folder. Verify all photos have been saved to the correct folder. Once all the experiments have been performed and images acquired, we are now ready to shut off the machine. Reduce current to 0 milliamps. Turn off the pulse generation switch. Turn off pump. Turn valve C2 to max V. Turn valve V1 clockwise to drain. Wait until all water has returned to the storage tank. Turn off the light, turn off the main switch. Close the HM132 software.